Hi there, and welcome back to another Papetti Math YouTube video tutorial where I am going to be teaching you, yes you, Algebra 1. And in this video, we're going to take a look at Lesson 2, where we're going to begin factoring trinomials, but the simple kind. So, in this lesson, you will be factoring trinomials that may not have a GCF. Multiplication fluency will be very useful when factoring trinomials. And what do I mean by that? I mean that knowing that 4 times 2 is 8 and 3 times 9 is 27 without having to use a calculator will be very helpful. So your multiplication tables up to maybe 12 times 12 is going to be very useful for this lesson and future ones as well. So in exercise number 1, it says, let's begin by deriving the rules for factoring a simple polynomial. So multiply the expression x plus 2 times x plus 5 and express your answer as a trinomial in standard form. So we're going to take what we learned from chapter 7 right now, and we're going to go ahead and we're going to multiply x plus 2 times x plus 5. And I'm going to use that method that I like to call the Lobster Claw. And that's when I take the first term in the first set of parentheses and distribute it to everything in the second set. So first I'll have x times x, and that's x squared. And then I'll have x times 5, and that's 5x. Then I'll do 2 times x, and I'll get 2x. And finally 2 times 5, and I'll get 10. And if I want, which I should, I'll combine my middle terms, and 5x plus 2x will give me 7x. And I'll be left with x squared plus 7x plus 10. And again, right here, you could see that lobster claw right there clamping down on my two expressions. So now it wants you to multiply the expression x plus 4 times x plus 3. And we're going to express that as a trinomial in standard form as well. So let's now multiply x plus 4 times x plus 3. Again, let's go back to the lobster claw, and we'll do x times x is x squared. X times 3 would give me 3x. Go to my second piece of the first set of parentheses, multiply that in every term in the second set. 4 times x is 4x, and 4 times 3 will give me 12. Again, I have like terms, so I'm going to have x squared plus 7x plus 12. So moving on to part C, it says, do you see a relationship between the original expressions and the final solutions? Describe a pattern between the original expressions, these up here, and the final solutions, these down here, and the middle term and constant term. So right now what I want you to do is, if you need a couple more seconds to see a relationship between these two things, pause the video and take a couple more minutes to look at them. If you think you know it, then keep the video unpaused, and we're going to look at it right now. So I see a 7 here, and I'm looking up here at a 5 and a 2 and a 5. And I see a 7 here, and I look up here at a 4 and a 3. Now, is there any way to get a 7 from a 5 and a 2, and also get a 7 from a 4 and a 3? So you might have said that you could add these two numbers to get 7, and when you add these two numbers, you get 7 as well. So that takes care of our middle term. But now let's look at our end term over here, our constant term. We have a 10, and up here we have a 5 and a 2. And over here we have a 12, and up here we have a 4 and a 3. Is there any way to get to a 10 using 5 and 2? And the same way we'd get to 12 using 4 and 3? And the answer is yes. If you multiply these two numbers, you'll get 10. And if you multiply these two numbers, 4 and 3, you'll get 12. So the pattern that we're going to describe is that in the original expression, the terms add to the middle term and multiply to get the constant term or the end term. So again, we multiply these two numbers to get the end term, and we add these two numbers to get our middle term. So we're going to be using that rule in our future exercises and when we get to more complex trinomials. But first, let's take a look at this next line right here. It says in algebra, the coefficients of the x squared term, the x term, and the constant are referred to as the a term, the b term, and the c term, respectively. So the standard form of a trinomial could be expressed as ax squared plus bx plus c. This will be very important to know going forth into our algebra curriculum. So let's actually erase the middle term that we have written up here and the constant term, and let's use our fancy new words now. We want to add to the b term, and we want to multiply to get the c term. So again, our b term is our middle term, and our c term is our constants. So now we're going to always say that we're going to find two numbers. We're going to be using two numbers that multiply to our c term and add to our b term. What does that mean? We're going to look at that more in depth in exercise number 2. For now, if this video was helpful in just deriving the rules for how we get from point A to point B, please give this video a thumbs up, and thank you for watching.